Can you hear me? Good afternoon, my name is Gonzalo Gutierrez, the manager of the desalination plant of Dalias field. Some of you will be visiting it tomorrow. And the plant belongs to the Campo de Alias cluster of companies. Veolia is the main partner. It is a French corporate group dealing with residues, energy and water cycle. These are figures from the last year. Some 96 million people are supplied with water. In terms of waste, we have dealt with some 47,000 tons, and we have produced some 45 million megawatts. It is a group which is mainly active in France, but is also present all throughout the world. I wanted to speak to you about the desalination process. Today, in the field of technologies, there's the reverse osmosis desalination, evaporation, electrodialysis, and we're going to focus on reverse osmosis because it's the most efficient process. It doesn't allow for large volumes of desalination. It's a process which will, depending on the initial water, we can prepare water on demand. Membrane manufacturers are improving polyamide membranes in order to reach conversion factors above 40%, and energy recovery systems are now being put in place. They are referred to as pressure exchangers, and the consumption of electricity is being reduced thanks to that. This you have on screen is a typical diagram of our desalination plant. The typical process envisages the capturing of energy. At the first step, we have the energy recovery reactor, remineralization, and then distribution to users. The capturing processes, depending on where the desalination plant is, we have different kinds of capture points. In the case of Dalias, we have an open field, but then we have wells, drainage systems. This goes onto a capturing vessel from where the water is pumped for the process to start. The first process is filtration. Filtration. Water should reach as clean as possible the reverse osmosis membranes. The bigger size for particles would be some 5 microns. Bigger particles would break the membrane, and different kinds of filtration are used. Open filters down to ultra filtration. As always, after filtration, there are the security or cartridge filters, which guarantee the biggest particle reaching the final membrane will be smaller than 5 microns. There you have some examples. These are the closed filters in Campo de Alias, in another plant in Águilas, in the province of Murcia. They are open systems. This is ultrafiltration, and these are the security filters of Campo de Alias. Once filtration is finished, we will enter the reverse osmosis process. At the reverse osmosis process, water goes through a membrane after being subject to higher pressure. The saltless water would go forward, and the pressure needed for the process to take place is between 35 and 65 bars, depending on the concentration of raw water. In order to improve efficiency, the pressure exchangers are being used, which reduce the energy cost of the process about 50%. And in the case of the Campo de Alias, there's a double-step osmosis because the limitation for boron to be present was about 5.5. These are pictures from the first step, and this would be the second step. which is more simple because we need less pressure for adding quality to the water. Once the osmosis process are finished, water has got to be remineralized, so it can be drank or used for things. We can use a layer for calcites or silage or lime saturators. Once we've done the remineralization, we will have the final water as a final product. In the case of the Campo de Elías, 50% of water is being used for human consumption and 50% for irrigation. The values reach a conductivity of 0.3 millisieverts. Boro is about 0.5 parts per million of boron, 0.05 in chlorine, and the maximum TDS is about 400 milligrams. As we should base our work on the official regulation for tap water, the users have got to mix up this water with continental water, so they mix it up so the conductivity reaches 0.05 millisiemens. The environmental impact is one of our concerns, and in order to, if there's any impact, it will take place in the sea, which is same location for discharge. Of course, local environmental agencies are checked, and there are studies for the capturing and discharge. We did our studies with the CDIX, where that water enters at a speed of less than 0.2 meters per second, and it is not compatible with the speed of fish schools, and usually it is discharged in areas where tides are strong. But in our case, we place a 2 kilometer pipe with parabolic discharges. The volume allowed a year for the discharge of brine was approved, and there's a specialized company which takes samples in terms of the quality of water and the problems we may have. These are the disseminators for discharge and the capturing tower. Another important thing is the energy cost. With former systems through Pelton turbine capturing, there was the cost was 3 to 3.5 kilowatts, and now we are 2.7 to 0.8 kilowatts. Both membrane manufacturers and regulation systems are trying to code to values around 2.2 kilograms per cubic meter. Thank you, that's all.